So we'll start off with something called systems of linear equations. And what that ultimately pertains to is, well, linear equations. That's the standard equation of a line. They can be expressed as y is equal to mx plus b, of course, with the rare exception where, or the exception where you have a vertical line, and that's just x is equal to a number. But when we think about systems, we think about a system being some sort of, space where we consider two or more linear equations going on simultaneously. And we'll work our way up to that. We'll just start off with linear equations, which in general refers to whenever you just have a single x floating around, no x squares, no x to the third power, just some x floating around. We could simplify all of these to, to represent something linear. And so the procedures for doing such, might be very familiar to everyone. Start off with example 1. You might already notice, hey, isn't that where you distribute the 27 to the x and to the -4? Yeah, that's exactly that situation. So this homework probably won't start off too challenging. We can go ahead and figure out that product right fast. So 408. And so from there, just bring together like terms. There's a few of them. Add 108 on both sides. We can also go ahead and combine the 5x and the 27x. 2x is equal to, what I'm guessing is 192. Let's find out. 192. And then from here, just divide both sides by 32. Pretty standard stuff to get x by itself. Divided by 32, and we just get 6. Very simple. So hopefully that wasn't too crazy for anybody, just standard high school algebra. Perhaps part 2, problem 2 here might be a little bit more difficult, might not be. Depends on how good you are with fractions. We did talk about this. We talked about this before, I believe in the beginning of the last unit, whenever we have fractions, what to do. Normally we used a least common denominator. And what would the least common denominator be in this case? 8. The 8, yeah. It's the smallest number that all the denominators divide into, the 8. Because 4 goes into 8 2 times, 2 goes into 8 4 times, and 8 goes into itself once. So remember what we do with that information. And I like to make a little bit of room to really emphasize that we multiply each term by this 8. And we look at these diagonal associations, you see that in every case, as it should, the denominator cancels out. This is exactly what the least common denominator is supposed to do. And so we write down everything that's remaining. X times 2 is 2x. There's a plus sign. 1 times, not 8, but 4. 4. There's an equal to sign. And then 1 times, 1. It's just 1. And notice this is much more simplistic to solve. That's all we have to do, subtract both sides by 4. Subtract. 2x is equal to -3. Divide both sides by 2, and we're done. So this should be pretty simple stuff. It should start off very easy for this homework, I would say. So does anyone have any questions before we move on? If not, let's go ahead and look at this following definition. So it's the formal form of a linear equation, which you might all remember is mx plus b, which is exactly what we have here. This is the generic form of a linear equation. And so keep in mind, m represents the slope, b represents the y-intercept. So again, fairly common topics talked about in high school algebra. The slope, based off of whether it's positive or negative, will determine how the corresponding line is slanted. Positive slope, which means m is greater than 0. Notice how the slant goes upwards from left to right. Negative slope is the complete opposite. Well, you could have a zero slope as well. A zero slope just means not positive or negative. It's completely horizontal. And an undefined slope, notice there's not even an m. There's no m here. It's just x is equal to a. There's no m because, well, we can't define m. So m doesn't make sense here. Instead, we just set x, we say x is equal to some number. And that represents a vertical line. So these are the 4 different situations. There'll be a few homework questions that ask you to make some observations based off of your slope and graphs, and what have you. So let's keep going and let's look at some examples, some ways we can use this information and manipulate certain things accordingly. Example 2 down here, for each linear equation, we're going to solve for an indicated variable and state the slope and the y-intercept. So this is normally, well, if we have something written out in y is equal to mx plus b form, the slope and the y-intercept are incredibly easy to find. You just kind of point to them. But what about if we are not in a y is equal to mx plus b form? Look at problem 1, for example. Well, they want us to solve for y, which means get y by itself. In a problem like this, how do we do that? Well, we would subtract both sides. 5x. The reason why, we're trying to get y by itself, so we work from the outside in. Cancel, cancel. Negative 6y is equal to negative 5x plus 30. Yes, that is plus 30, because 30 was positive. And we're keeping it in this form to be consistent with mx plus b. But we're not done, because y is not fully solved for. Now we need to divide both sides by negative 6. And from here, what we get is that y is equal to, well, dividing by negative 6. There's 2 terms in the numerator. There's negative 5x, and there's the 30. So really, in essence, what this breaks down to is that both of these terms are being divided by negative 6. And so negative 5 divided by negative 6, there's not really much we can do there. If you try to put that in the calculator, it'll just give you 5/6. But 30 divided by negative 6, that will give us something nice. That'll give us negative 5. So negative 5. So we have now solved for y. And that's very helpful because for part B, they want the slope which we can identify very quickly. It's just the number in front of the x. So that'd be 5/6. And the y-intercept is, well, the other number that's off to the side there, the -5. So that would conclude this problem. Does anyone have any questions before we continue? Imagine it's fairly familiar stuff. Let's look at problem 2 just in case. So they want us to solve for c. So we need to get c by itself. So the first thing we need to do is subtract 32 on both sides, because we first want to get the c term by itself. So this brings us a little bit closer to that goal. Now the c term is by itself, just the term that has a c in it. But the problem is, well, they want us to, well, get c by itself, and there's a fraction in the way. Now, normally the way I think about this is I multiply both sides by the denominator. So we can get rid of the denominator down here, the 5s. But there's one thing that we need to make sure we put, or we might get misled. We need to put parentheses around that f minus 32. Definitely have to put that. We're multiplying 5 to the whole term, not just the f. We would have rewrote the problem with the -32 in front. Would have been the same idea. Now, I think this is one of those nitpicky MyMathLab things. You put the answer as a multiple choice, but I think for this problem, they leave it in this format. I believe so. I think they leave the 5, eventually 5/9, and they don't distribute it. Can't necessarily remember. Maybe we'll do it both ways, just in case. Let's just suppose that they leave the 5 outside. I can't remember. I think it's one of those weird MyMathLab situations. But to get c by itself, we can divide both sides by 9. And that fully gets c by itself. So c is by itself, and what's on the other side? Well, the 5 and the 9 can be joined together. Since everything is being multiplied to each other, we do not have 9s dividing each individual part. So we would not have a 9 dividing the f minus 32, because everything's multiplied together. They are not term by term. So there's only one 9 here. And I joined it with the 5 because it's very concise. So I can't remember if MyMathLab keeps it like this or if they distribute it. I'll do both just in case. So if we distribute this to put it in actual mx plus b form, then 5/9 times f is just 5/9f minus, well, 5/9 times 32. So let's figure out that one really fast. 5/9 times 32. Not a very nice number, so let's click math, fraction. Just like that. So again, I can't remember which form they put it in. Whichever one they do, this should be plenty sufficient in helping you solve that problem. Now they want us to determine the slope and the y-intercept. Well, I'll just point some arrows. The slope is 5/9. The y-intercept is -160/9. So that concludes that problem. Does anyone have any questions before we look at intercepts and graphing? If not, let's go ahead and look at, well, what I just mentioned, intercepts. So intercepts are a part of a linear equation. We can have two different sorts of intercepts, and as the name implies, an intercept is a part of the line that intersects the graph at a particular spot. Now, the graph can be intersected at, well, really, it can be intersected at the x-axis or the y-axis. So that's why there's two intercepts. The x-intercept is any value whenever y is equal to 0. Notice it's opposite in a sense. You find an x-intercept when you set y equal to 0. You find a y-intercept when you set x equal to 0. So it's the opposites, and you'll see me do it a few times throughout this section here. So let's go ahead and do this for example 3 and figure out how that helps us graph this equation. So for this equation, I'll just rewrite it right here. We need to find two things. The x-intercept and the y-intercept. Let's start off with the x-intercept. How do we find this? We set y equal to 0. So then we have 2x plus 3 times 0 is equal to 12. So notice I just rewrote the same equation, and I switched out y with 0. Now normally when I substitute, I have a habit of using parentheses. It's a good habit. Whenever you substitute any number or value in, definitely want to use parentheses. It scales very well for later problems. But anything times 0, of course, just 0. So it simplifies very nicely. Then x is 6. Just divide both sides by 2. So what we just found, well, we just found the x-intercept. And what this corresponds to is the ordered pair of 6, 0. That's what we just found. It's two ways of representing the same information. Now, how do we plot this on the graph? Well, an x value of 6, a y value of 0 would go right here. And you will notice that there is an interactive graph, I believe with this problem, where you would go in and you would click, I want to construct a line, and to construct the line, it'll ask you to plot 2 points. And this is one of the points that you would plot if you had an example like this or similar to this. Now we can also find a y-intercept. Because to plot a line, we need 2 points, and then just draw a line right through them. And that's your line. You can set x equal to 0 instead of y. So instead of 2x plus 3y is equal to 12, it's 2 times 0 plus 3y is equal to 12. And just like the previous problem, 0 simplifies stuff very nicely. So we're just left with 3y is equal to 12. Or more simply, y is 4. I don't think I've really asked any questions today. What's the ordered pair here? Yeah, it's 0, 4. All right, good. I didn't trip you all up. It's 0, 4, not 4, 0, because the x has to go first. And we said x was 0. That's how we facilitated this whole process. So same bit of information characterized slightly differently. The y-axis was the vertical one. The 4 is right here. And so if you were doing this in MyMathLab, you click the line tool. It says, I want 2 points. You would click both points and it will draw this perfect line for you. Well, I don't have that. I'm going to use a ruler to try and make this as neat as possible. Wish me luck. Let's see. Okay, not too bad. So it'll do that for you. And that's it. That's all you do for this problem. They just wanted you to graph it. And generally, the easiest way to graph a function is to find its intercepts. Now, there's other ways you can graph functions. You can write it in mx plus b form, and then use the slope and the y-intercept. But if you can use intercepts, which most of the time you can use them without issue, then that works out very nicely. Does anyone have any questions before we move on? If not, let's keep going. And we will move on to the main component of this section, which is now we're looking at systems of linear equations. So in this class, we're going to be looking at a system of 2 linear equations, or maybe 3 in some aspects throughout this chapter. And the system just represents a space in which 2 or 3 or however many linear functions exist simultaneously. Now, this would just be a statement of linear equations, either 2 of them or 3 of them, as you can see below here. To solve one of these systems means to determine what the x and the y value have to be. Or in other words, geometrically, to solve a system of linear equations is to find the point or points for which the lines intersect. So that's ultimately what we're trying to find. There's some lines that are occurring, they intersect somewhere. We want to figure out where do they intersect at. So we're going to start off with, well, really, there's 3 ways to solve a system of linear equations. There's one way, which is graphing, and then there's 2 other ways, which we'll talk about, addition and substitution. We'll start off with graphing at first. Now I'll start with problem 1, because this is another one of those MyMathLab things that really irked me. So yeah, I've probably said this a few times. I don't write the homeworks in this class. I don't write the tests. I don't write anything other than these notes. And with that, there's a problem like problem 1 here that you'll probably get. I think it might be problem 13. And it says to solve the system by graphing, which means you would draw 2 lines and try to really closely figure out where the lines intersect. The problem is the points have fractions in them. How are you supposed to figure out where a third is at? They don't fall on the grid lines very nicely. That's kind of frustrating. So I wanted to talk it through and explain how I would go about this problem. Because for part 1 here, problem 1 here, graphing will not help you. And it tells you to use graphing, and it will not give you any other specifics other than that. So let's kind of see where this problem arises. So if you try to take each line, so normally what I would do is I would take each line here. Here's the first one. I'll just take that one off to the side. So generally you would want to find the intercepts. You want to go ahead and find the intercepts. So if you go to find the x-intercept, remember, you set y equal to 0. So 0 is equal to 3. And of course, 4 times 0, that works out very nicely. That zeroes out. Negative 3x is equal to 3. X is equal to negative 1. In other words, we get the ordered pair negative 1 comma 0. So for the very first line, we get the point negative 1 comma 0, which we can plot. So you might think, all right, that's pretty straightforward so far. Okay, let's find the y-intercept. Well, we set x equal to 0. Negative 3 times 0 minus 4y is equal to 3. We're still going off of the same equation we started with. Negative 4y is equal to 3, or in other words, y is equal to negative 3 over 4. Or in other words, the ordered pair 0 comma negative 3 over 4. Now the good news is, well, the initial problem of this is that for certain problems, you can't really graph fractions using their line tool. Now for this problem in particular, it's a multiple choice problem. So I'm going to graph it as close as I can and just make a line out of it. So you're not responsible for having to graph this one by hand like you are, say, the next part you would have to. But this problem, you're not, they'll have you just find the multiple choice for it. So negative 3 over 4 would be right about here, slightly above negative 1. We can go ahead and connect the dots here and form a line. Again, it's multiple choice, so it doesn't have to be perfect. So mine's definitely not going to be. So this is just one line. This is a system of 2 lines, though. So we need to figure out information about the second one. So we did all of that for the first line. And I like to put L1, just to say the first line. So this was all the stuff pertaining to L1. And then we'll do everything for L2 over here, which the second line here is 6x plus 5y is equal to negative 6. That's the second line. Here's the first line, here's the second line. And so we're going to, just like we did for the first one, try to graph this one. We're going to find the intercepts and see where that goes. Start off with the x-intercept. We set y equal to 0. So this is 6x plus 5 times 0 is equal to negative 6, which, again, intercepts are very nice to work with. 6x is equal to negative 6, or x is negative 1. So I'll go ahead and skip some of these algebraic steps that are a little bit more tedious now. So that is at negative 1 comma 0. Now, that already actually tells us the point of intersection. I didn't mean to pick a problem that had such an easy point of intersection, so I'll have to explain another way of how to do it, because I saw some that had some pretty unique points of intersection. Let's go ahead and set x is equal to 0. Okay, let's see. So 6 times 0 plus 5y is equal to negative 6. 6 times 0, 0 is out. 5y is equal to negative 6. Well, of course, we divide. And I'll go ahead and write that y is equal to -6/5. In other words, the ordered pair is 0, -6/5. How do we plot -6/5? That's -1.2. I would go about right here. And I'll use red to distinguish this line from the first one. So let's see. About this will be line 2. Now, in this case, the point of intersection is clear because they both have the same x-intercept. Point of intersection is the point for which the two lines cross through. And this is very easy to determine based off of this graph here. I think what I would like to do is, if I have enough time at the end of class, I'd like to work out another example. I'll just pull up my MATLAB and work out that one when we get to that. I'll talk about what to do in that situation. But that's the ultimate idea of solving a system by graphing. It's not always the best choice because sometimes your graphs are just, well, if you're drawing them by hand, it's not a very good way of determining the point of intersection. Your graphs may not be perfect. Of course, using MyMathLab, the lines will be exact, and it gives you more of an idea. But yeah, they do have you do a few solved by graphing problems. Does anyone have any questions before we look at one that might be a little bit more straightforward? Okay, let's look at problem 2. So they give us two lines. They want us to, yet again, find the point of intersection between these two lines. And so I'll go ahead and identify the first line, 2x minus y is equal to 10. And additionally, I can go ahead and put L2 on the other side. X plus 2y is equal to 5. Okay, so what we need to do, we find the intercepts. In the x-intercept, we set y equal to 0. This is 2x minus 0 is equal to 10. Simplifies very nicely. 2x is equal to 10, and thus x is equal to 5. Which gives us the ordered pair, 5, 0. From here, we go ahead and plot 5, 0 right there. Let's figure out the other points. So what about the y-intercept? We set x equal to 0. 2 times 0 minus y is equal to 10. Anything times 0 works out very nicely. Negative y is equal to 10, or in other words, y is equal to -10. By just bumping the negative over to the other side, which this corresponds to the ordered pair 0, -10, which would be all the way at the bottom down here. And we can use all of this to construct our line. Okay. So that's the first line. We have to do the exact same process for the second line. x-intercept, again, set y equal to 0. So remember, we have a new equation now. It's x plus 2 times 0 is equal to 5, which is x is equal to 5. And it works out pretty much exactly. So this corresponds to the ordered pair 5, 0. Which we already have plotted. So that already tells us the point of intersection. The y-intercept, we set x equal to 0. So that's 0 plus 2y is equal to 5. So it's 2y is equal to 5, or y is equal to 5 over 2. Which corresponds to the ordered pair 0, 5 over 2. Now, I mentioned earlier that you can't really plot fractions using the tool, and they will have you graph this. However, they have 0.5 increments that you can utilize. So you can plot 0.5 increments, and 5 over 2 is 2.5. So on my graph, it doesn't show the half increments. They only go by increments of 1, so we'll just have to do this in between 2 and 3, right in between 2.5. And I'll use red to connect this line. So line 1 and line 2. And from here, we can see what the point of intersection is. It seems to be 5, 0, which I normally call the POI, point of intersection. So 5, 0 would be the solution to this linear system, the system of linear equations. To solve a system is to find where the point or points of intersection lie. Does anyone have any questions before we move on? If not, let's look at other ways to solve systems. We can solve a system by using something called the substitution method. And the substitution method requires you choose one equation. With that equation, you get one variable by itself. It doesn't matter which one. And then you're going to plug that or substitute that value into the other equation. Now, to explain this a little bit more thoroughly, in problem 1, we have a system of 2 equations here. There's the top one and the bottom one. Well, in general, we would need to choose one of these equations and isolate one of the variables, as in get it completely by itself. The good news here is, well, one of them's already isolated. So it makes our choice pretty easy here. So we want to, really what we want to do is substitute the variable we solved for into the other linear equation. So what's the other linear equation? It's the x plus 3y is equal to -1 equation. So what did we find? We found that y is equal to -2x minus 12. So this value of y, go right here. We can just switch them out. X plus 3, but we're not going to put y anymore because we see that y is equal to negative 2x minus 12. And this is where the parentheses really help when you substitute. You need to put parentheses because you need to know that that 3 has to distribute to those terms. If you don't put the parentheses, you might actually just think it's a subtraction. 3 minus 2x minus 12. It's a distribution. X minus 6x minus 36 is equal to negative 1. And from here, we clean it up and find x. Well, we have x minus 6x as like terms. We need to add 36 on both sides to get the other like term. So that's negative 5x is equal to, well, 35. Or in other words, x is negative 7. So we just found the x value. But we're not done. Because we need to, whenever we solve, we need to find the point of intersection. What does every point have? An x and a y. We don't have a y yet. So what do? We plug this back into the original substitution that we had to figure out the y value. Now we have y is equal to negative 2x minus 12, which is now equal to negative 2 times negative 7, the x value we found, minus 12, and that's just 2. So it's just 2. So really our final answer, negative 7, comma 2 as an ordered pair. So we found the x value and the y value. So does anyone have any questions before we proceed? If not, let's look at problem 2. Let's look at another situation of the substitution method. Now, the goal with the substitution method, you have to pick one of the two equations and solve for one of the two variables. Now it's a little bit more complex. I'm going to pick the top one because there's less numbers. It seems like an easier equation. And I want to solve for any one of the variables. Any one, it doesn't matter. In fact, I'm going to solve for x because to get x by itself, all I have to do is just add y on both sides. X is equal to 1 plus y. And so I accomplished what I initially needed to. I picked one equation and I isolated one of the variables. I picked the top equation and I chose to isolate x. You can definitely isolate y if you want to. It doesn't matter. It's going to work the same way. So now we're going to substitute this into the other equation. The other equation was 7x plus 3y is equal to negative 53. But now we have a substitution or a replacement for x, because that's what we solved for. So instead of x, we can put 1 plus y plus 3y is equal to negative 53. We can distribute the 7. 7 plus 7y plus 3y is equal to negative 53. We have some like terms here. And we can subtract 7 on both sides. 7y plus 3y, that's 10y. And then we get negative 60, negative 53 minus 7. Or simply y is negative 6. But we're not done. We need a point of intersection, which means we need an x and a y. We're missing an x. So we need to plug this back into our substitution equation. Let's go ahead and do this on this side. So we have x is equal to 1 plus y, but now we know that y is equal to negative 6. So we simply get negative 5. So the point of intersection, or the ordered pair that solves the system, is negative 5 comma negative 6, where I'm putting the x value first and the y value second. Does anyone have any questions up to this point? If not, well, personally, I don't like either two of those methods. And I personally like the following method. I think it's the most simplistic. And you don't, even though the homework might tell you to use the substitution method, or it might ask you to do the addition method, it's not going to know which one you do. You can use either one you want. And I figured I'd show you both of them. But personally, I like the elimination by addition method. And so what we do here, so notice it's a very similar premise. So what we're doing is we're adding equations together in hopes that we cancel out one of the variables. So we're going to be adding these equations together and pretty much adding like terms together. So the addition, I'm just going to rewrite everything. Now here, I want to add these equations together because the y's cancel out. 3y minus 3y, so we're viewing this as columns. We're viewing this as like terms. 3y minus 3y, they cancel entirely. 4x plus 3x is 7x. 16 plus 12 is 28. So notice we just get 7x is equal to 28. No need to solve for anything. Divide both sides by 7, we're done. X is 4. Notice we already have x. No substitution needed. No graphing needed. No intercepts needed. So, but we need a y value as well. We have just an x. So we need to plug this into really either equation. I'll pick the top one. They both seem pretty much the same. So I'll pick the first equation. 4x plus 3y is equal to 16. That's the top equation. I'm just going to plug in 4 for x. It doesn't matter which one you pick. Plus 3y is equal to 16. All we have to do is get y by itself. 3y is equal to 0, or in other words, y is 0. So ultimately what we found is that the point of intersection is 4, 0. So I personally like that method the most. And I'll explain it again in the next problem. Does anyone have any questions so far? Okay, if not, so you might think this seems to be, well, it may be more simplistic, but isn't that because you had a very specific situation? Doesn't that only apply to specific situations? And it just so happened that the 3 and the -3 were just right there waiting to be canceled. In this example, we don't have anything that could cancel like that. So the question is, can we still apply this process? The answer is actually yes. We can apply this process. We just have to do one intermediate step. So you can do this for any problem. So something we can do. So the problem, well, the convenience of before is that we had two coefficients that were the same magnitude. They were both 3's, but were different, were off by a sign, which was perfect because when we added them, they canceled. We don't have that over on our new problem. There's no 4 and -4. There's no 3 and -3. But if we can force that to happen, then we can do that same process. So what we need to do, we can multiply any equation by any number we want, provided we do the same thing on both sides of the equation. Now, let's say I want to cancel the x's out. I want to cancel the x's out. Well, I need to make one of these coefficients 2 and one of them -2, or I can make the top coefficient -4 and the bottom one 4, or any combination of that. So really, what I want to do is I want to multiply the top equation I'm going to multiply the top equation by -2. And I'm going to leave the bottom equation alone. And so by doing this, as long as we do everything balanced, as in we multiply -2 to every single coefficient, so that's -4x minus 6y is equal to -8 for the top one. And 4x plus 2y is equal to -8. So as long as you multiply that -2 to every single number for the corresponding equation, then you're okay. And so now we basically just change the problem we're looking at. And now notice we have a -4 and a +4, which means we can add them together. So we can now add these two together. And exactly what we wanted, -4x and +4x cancel. And we can just add column by column still. It's -4y is equal to -16. It's not 0, it's -16. And so we can quickly figure out that y is +4. So this process can be applied to any system as long as you might have to do a little bit of work by multiplying one of the equations to make the coefficients line up in a certain way. But we still have to figure out x, which means you have to take any equation, either one of the two equations. I'm just going to pick the top one. And we're going to plug in y is equal to 4. 2x plus 3 times 4 is equal to 4. Plus 12 is equal to 4. 2x is equal to -8. X is -4. So altogether, we get a point of intersection of -4, 4. And that would solve this system of linear equations. You're welcome to use either method that you please. You're not forced to use either one. If it says you have to use the substitution method, then you don't have to. It's not going to know any different. You're still going to get the same answer. Graphing, though, it will make you do that, but to figure out the point of intersection of a graphing problem, you can use one of these two methods instead. And it might actually be easier. Does anyone have any questions before we look at some corresponding word problems? Let's go ahead and look at these three. Okay. Example 7, there's some delivery service. They charge a base price for anything weighing a pound or less, and then a surcharge for each additional pound. They tell us that some customer is billed $23 for shipping something that's 7 pounds and is charged $41.75 for shipping something that's 22 pounds. They want us to figure out what the base price and the surcharge are. So the problem with these word problems is, well, somehow we need to take those words and turn that into a system of linear equations, which may or may not be fun depending on how you view all this stuff. So if anything, we need some variables. We need an x and a y. Let's make the x, ultimately, it really doesn't matter will we make the x or the y. Let's make x the base price. Let's make y the surcharge. So what has to happen for them to determine a bill of $23 for a 7-pound package? So what it says is you're going to be charged a base price. You'll be charged a base price anytime you ship really anything. There's the base price right there. In addition, you will have to pay a surcharge for every pound after the first pound. Now, if there's 7 pounds in total, every pound after the first one, 6 pounds left over. So for each pound afterwards, you will have to pay the surcharge, and that will construct the bill. So no matter what, the base price is the price you will have to pay to just use the service. So you're always adding that, x. The surcharge is for each additional pound. Right, that's one of the equations. But this person also paid $41.75 whenever they sent out a 22-pound package. So you always have to pay x, but you have to pay the surcharge for every pound after the first pound. There's 22 pounds. Well, every pound after the first one, that's 21. And that's where the $41.75 comes from. Here is our system. So this is our system now. We've translated the word problem into a system. And now we need to solve the system. Now, I really haven't been asking you all too much. How can we solve the system? Yeah, that definitely helps that those x's are just the same magnitude, just need them off by a sign. So what I'm going to do, maybe I'll write out the intermediate steps in case anyone's confused. I'm going to take well, really it doesn't matter. We just need one coefficient to be positive and one to be negative. I guess I'll take the top equation and multiply it by -1. The reason why is that I want the coefficients to have this, for any one of the variables, it doesn't matter, to have the same magnitude and just be off by a sign. -1, that distributes to everything. Now it's negative x minus 6y is equal to negative 23. So notice the top equation changed. I balanced it out by making all the numbers scale appropriately. And then the bottom equation stayed the same. And this is perfect, because now when we add these two equations together, the x's cancel, because they have different signs. And then we just add up the other like terms. So this is pretty much 21 minus 6, that's 15, is equal to some number. Let's find out. This is pretty much 41.75 minus 23. 18.75. And then there's going to be one more division by 15. 1.25. So what we found, we just found the surcharge. It costs $1.25 for each additional pound that you ship. That's what we found. But we need the base price. We don't know the base price. Let's find the base price. All we need is any one of the equations. I'll pick the top one. It really doesn't matter. You'll get the same number. We're going to plug in 1.25 for y. Was it $7.50? 7.5. And so we get that the base price, what you have to pay to just use the service every time, is 23 minus 7.5, which is 15.5, or $15.50. You don't really need to write it as an ordered pair. I think they just ask you for what's the base price, what's the surcharge, and you would just put them in as separate blanks. Anyone have any questions about that one? Let's look at example 8. Okay, so there's animals in some experiment, and they have to be on some particular diet. They need 20 grams of protein, 5 grams of fat. Mix A has 20% protein, and mix B has 40% protein. Mix A also has 8% fat, and mix B has 4% fat. How many grams of each mix should be used? Okay, so it's going to be another system that we set up. And it's going to start off the same way. We need to figure out an X and a Y. In words, does anyone happen to see what X should represent and what Y should represent? For some words. So X, so notice what we're trying to find. Notice the last sentence here, the last question. How many grams of each mix? How many grams of each mix? So it's not necessarily the protein. It's going to be the grams that correspond for mix A and grams for mix B. So that's really what the variables represent here. It's the grams for mix A and the grams for mix B. And so each individual variable will help us determine exactly how many grams we need for each. So for mix A, well, for both of these, the protein is going to get its own equation, and the fat is going to get its own equation. And we know that the total number of protein is 20, the total number of fat is 5, because they say each animal should receive 20 grams of protein, 5 grams of fat. So that's why I have 20 and 5. Now mix A has 20% protein. So 20% is 0.2 x. And so it goes on to say mix B has 40% protein. We're trying to keep all the protein values together. So plus 0.4, because there's 40% protein for mix B. So 40% is 0.4. So I'll write out 0.4y. And that's for the protein. So notice I'm keeping all the protein values consistent. I'm going to do something very similar for the percentages of fat. So mix A has 8% fat, which is 0.08. And then mix B has 4% fat, which is 0.04. So ultimately, we're setting up a table of these values, but doing this in a specific way to where we can identify what the unknowns are and solve for them. So we have this equation, this system of linear equations now. The question is, how do we, ultimately I would suggest just using the substitution method, I mean not that one, the elimination by addition method. The question is, what would we multiply to one of these two equations such that we can use the addition method immediately? What can we multiply to either one of these two equations such that we can use the addition method? Does anyone happen to see anything?
You can multiply the bottom equation by 10.
We're going to multiply the bottom equation. I'm going to do negative 10. It'll be two birds, one stone, kind of an ordeal. So 0.2x plus 0.4y is equal to 20. So the top one's going to stay the same. It's got the bigger numbers. We're going to leave that one alone. The bottom one, so I'll just rewrite it. But I'm also going to put a product of negative 10. And the reason why I'm using negative 10 is because we could see when we distribute this, we will get two coefficients that have the same magnitude and different signs. So the top equation stays the exact same. So what happens to the bottom equation? Negative 10 times 0.08 is negative 0.8 minus, well, negative 10 times 0.04 is just 0.4. So notice that's exactly what we wanted. And that's equal to negative 50. So from here, all we have to do is add these two together. Because once we add these two together, we get a cancellation of these y terms. Because we're adding these two terms together. They cancel out. And now we bring everything else together. That's negative 0.6x is equal to, really it's negative 30. And then to solve for x is equal to negative 30 divided by negative 0.6. was it like 50 or something? 30 divided by 0.6 is 50 grams. So this tells us that we would need 50 grams for mix A. 50 grams for mix A. So now the final question is, how many grams do we need for mix B? Well, we have to pick either equation. I'll just pick the top one. We need to find y. Pick the top equation, 0.2x plus 0.4y is equal to 20. I'll plug in 50 for x. So 20% of 50, I believe that's 10. 10 plus 0.4y is equal to 20. 0.4y is equal to, let's subtract 10 on both sides, just 10. So y is equal to 10 divided by 0.4, which is probably 25. Wait, no. 25, yeah. 25. So y is 25. So that would be grams for A would be 50, grams for B would be 25. So we had one more example for this section. This is example 9. And this is, as you can see, a word problem. There is a company that sells DVDs. They sell them for $24.95, which includes shipping and handling. And they also tell us that the cost for selling or manufacturing these, as well as all the other subsequent costs, was $25,740 for fixed cost, which is something that they will have to pay no matter what. And then variable cost, variable meaning it varies depending on how many DVDs are manufactured. So with all this information, they first want us to write a system of equations that consists of the cost and the revenue function. So basically, what is a function that talks about the cost of everything versus the revenue? Now, I'm going to write it instead of y is equal to mx plus b, because these are ultimately just lines. So lines can be represented in this way. I'm going to use, for the cost equation, I'll use a C instead of a Y, and for the revenue equation, I'll use a capital R. Now, the cost, it does say for the cost that there's fixed cost of $25,740, fixed implying that, am I muted? Can anyone in the virtual hear me? Am I muted? Yeah, it says it's on my end, so I'm not too sure. Okay, you can hear, yeah, Carly, if you can, I guess you might not be able to hear me. So I'm going to assume that everyone can hear me virtually just fine. But let's keep going. So with the cost equation, as I mentioned, the fixed cost, $25,740, that's something you have to pay no matter what. And the variable cost, $5.45 per DVD. Now, normally when you have a variable cost, it's a cost or a value that's near a variable. Makes sense. So the $5.45 per DVD, the number of DVDs will represent X. So the more DVDs you have, you will multiply that by 5.45. And then the fixed cost is something you have to tack on top of this no matter what. It says that the fixed cost is $25,740. So that would be the cost function. And the revenue function, the revenue equation, well, revenue means the money that you earn. So this company earns money whenever they sell DVDs. How much do the DVDs sell for? Sell for $24.95. So for each DVD you sell, you get $24.95. So that would be the revenue function. So the top one would be the cost function, the bottom one would be the revenue function, and here X represents the number of DVDs. And now what we have done is we've set up a system. We've set up a system of linear equations. So we have two linear functions, two linear equations existing in the same space. Now, how many DVDs must be sold for the company to break even? So of course, it costs a lot of money to make the DVDs, and then you're selling these DVDs. So you're wondering, well, how many of these do you actually have to sell in order to, as it says, break even? So to break even, your cost has to equal your revenue. So the amount of money you earn has to equal the amount of money you spent for that corresponding number of DVDs. So we know what the cost function is. It's 5.45x plus 25,740. This is equal to the revenue function, which is 24.95x. So we're setting the two functions equal to each other. And what this allows us to do is to find where the two lines will ultimately intersect. And so really it's just a matter of combining like terms. You can subtract 5.45x on both sides to get those two next to each other. And so we can go ahead and make that calculation right fast. $24.95 minus 5.45, 19.5x. And then all we have to do is get x by itself. So to get x by itself, x is equal to 25,740 divided by 19.5. That quotient will yield the final answer. 25740 divided by 19.5. So they need to sell exactly 1,320 DVDs, because remember, DVDs represents X. That's how many DVDs they have to sell in order to break even. And this is determined by setting the cost function equal to the revenue function. Does anyone have any questions up to this point? If not, so they want us to graph the above system as well. Now, the good news here is for this part of the homework, this is a multiple choice, so we don't have to be too rigorous in this. Something you might notice though is that this graph only shows the first quadrant. It's not a full graph where you see the negative x values and the negative y values. The reason why is that this is a word problem that deals with number of DVDs and money. So we're not really looking at negative quantities in this word problem. So really all we have to do is just graph the lines roughly and then choose the, or on your end, choose the corresponding system of lines ultimately. So I'll just write the two equations over here. And the good news is that since they are already in mx plus b form, we can graph these very easily. Because at least, well, for the cost function, we get that the y-intercept is 25,740. So all we have to do is figure out, okay, about where does that exist on the y-axis. So to figure out the increment sizes of this, so it goes 1, 2, 3, 4, 5, 6, 13. I can guess how much these would be. 5, 10, 15, 20, 25, 30, 35, 40, 60, 65. So they go by roughly 5,000 increments of 5,000, a little bit more. Again, it doesn't have to be perfect, it's multiple choice. So really what we can do, that's 5, 10, 15, 20, 25, it'd be about right here. About close enough to 25,740. And again, because this is, since this is kind of informal, using multiple choice, all we need to figure out from here is really use the slope to help us determine the slant. So the slope is 5.45. So I'll keep everything in red. I want to do this all in red. Slope is 5.45, which is indicative of a positive slant. So we will be slanting upwards. So again, it doesn't have to be perfect. So we get some sort of upward slant, which I'm resembling here. And because the number is fairly small, the slant's not going to be very much slanted. It's going to be kind of slanted because our slope is kind of a small number, just 5. If that number was 20,000, then the slope would very much be slanted a lot more. Additionally, the revenue function, which I'll illustrate in blue, the y-intercept for the revenue function, they don't really have one. It's normally mx plus b, but there's no plus b. So really the y-intercept is 0, which tells us about right here. That's the y-intercept. And then from here we see that the slope is 24.95. So it's a little bit larger of a number, which means we'll have a little bit larger of a slope. So we'll have something like this. I think for the multiple choice aspect, it'll be very clear which two lines it would have to be based off of their y-intercepts and the slopes. I think one of them might have a negative slope, which you shouldn't have in this problem. But this gives you an idea of how these lines are roughly constructed. And so this is us graphing the above system. And ultimately, the break-even point is right there where they intersect. Which we already know what the point is, so we don't need to go into that any further. But they do ask, based off of the graph, what does the region between the lines to the left of the break-even point represent and to the right? So they want us to know, in part D, what does this region represent? And so what this region actually represents, well, the red line is above the blue line. The red line represents cost. So it's saying your cost is higher than your revenue. So this represents where you are, I'm trying to remember the exact terminology they use in the homework. What is the region between the lines to the left? I think it's represents I believe it's a loss of profit. believe that's what it says. There's some multiple choice part. The loss of profit. Because your cost is higher than revenue, which means you're losing money. And then they ask, what does the region between the lines to the right of the break-even point represent? To the right of the break-even point? Well, break-even is where the points intersect. And notice how the lines alternate. Now the revenue function is on top of the cost function. So this represents a gain of profit. Represents a gain of profit because the revenue is higher than cost. So revenue is higher than cost there.